If not, this is where we left off yesterday. Yes? Yep. Now these here, it wants us to find all 6 trigonometric functions. Really 5, because it gave us 1. It told us the value of tangent. The tangent of this angle is equal to 15/8. Now with most of these here, if you're not sure how to make it or solve these here, make a triangle. Now, especially if they give you sine, cosine, tangent, secant, cosecant, cotangent, and give you more information about it, we're definitely going to need to put it on the xy coordinate plane. Now, the reason for this is because it told us tangent is 15/8. Tangent's opposite over adjacent. And it also told us sine is positive, because sine of theta is greater than 0. It's just telling us that it's a positive value. So if we look at the unit circle or talk about the unit circle, sine is theta is greater than 0 in the first quadrant and the second quadrant. So the 2 places where sine can be positive is the first and second quadrant. Now tangent is also positive. Tangent is positive in the first quadrant, and it's positive in the third. So is it possible for this angle, to be in the third quadrant? No, because sine for this, because again, it told us sine has to be positive, and we know tangent is positive. So the location of this triangle is in the first quadrant. We can set it up there. Because the only other way for tangent to be positive if sine was negative. Sine and cosine are both negative, it's positive. Sine and cosine are both positive, it's positive. So really this information is one, this gives us some actual information about our values itself. This is giving us more information about the function. Where is this angle in relative to all of our other points? So here, first quadrant. Tangent is opposite over the adjacent. So when we set our angle up, opposite over adjacent, these are always going to hold true. That's why I was questioning the problem yesterday, because the opposite adjacent, those weren't holding true if when we set the triangle up from our answers. So I was able to figure out that I mixed up the formulas. And again, I'm not expecting you to memorize those. I will have reference sheets. You will write them down. Do not memorize those. There's no reason to. Because most likely after this class, you will never use them again. No reason to memorize them. So, if we look at this here, we have the adjacent side, the opposite side of the triangle. We're missing the hypotenuse. So we can get it at 2 ways. One is our a squared plus b squared equals c squared. And the other is r is equal to x squared plus y squared. These are the same formula. Because the only difference is that the first one uses a, b, and c instead of x, y, and r. And the only other difference is that they actually took the square root of both sides. Same formula, same direction we'd get. Because here, if I just took the square root of both sides, this just becomes c is equal to the square root of a squared plus b squared, what we're trying to find. So really what we're looking at is r is equal to the square root of 8 squared plus 15 squared. We can plug this in a calculator. Second square root, 8 squared plus 15 squared is 17. Which means the hypotenuse of this is 17. Out of all 6, there was one we didn't even have to do any calculations for technically, and that's cotangent. Because cotangent here would be 8 over 15. It's just the flip of tangent. Now looking at our triangle, the opposite side to the angle is 15, yes. 17 would be the hypotenuse, so sine would be 15 over 17. Cosecant would be, yes. Cosine's adjacent over hypotenuse, so it would be, and secant would be, and that's it. And really, this is about as complicated as it gets. We take the given information, set up our triangle, and go from there. Questions on this here? Sine of theta equals 0.6. Theta lies in what quadrant? So it lies in the second quadrant. That means our values are going to be over here in the second quadrant. Now there's different ways we can do this. We'll do it with the triangle here in a minute. But if we want to find these values, well, sine is 0.6. So if we want to find cosine, we'd say sine squared of theta plus cosine squared of theta is equal to 1. This is our trigonometric, or our Pythagorean identity. Sine has already been told to us to be 6 squared plus cosine squared is equal to 1. Now if we simplify our 0.6 squared, so it would be 0.36. 0.6 squared, 0.36. Now at this point we can subtract our 0.36 from both sides. These cancel, telling us that cosine squared of theta is equal to 0.64. And last but not least, we'd square root both sides, telling us cosine of theta is equal to 0.8. Questions on this so far? Now, one of the interesting things with this is that we said we were in what quadrant? 2, yes? Cosine is negative in the second quadrant because it's the negative x. So cosine would be negative, which means our cosine value is negative 0.8. We have to take that into account. And now that we have this, well, we do have the rest. Since cosecant is negative 0.8, secant of theta is 1 over cosine's value. So it'd be 1 over negative 0.8. In the calculator, we can do 1 over negative 0.8, which is negative 1.25. So we have cosine. We now have secant. We can also get cosecant, because cosecant is 1 over sine, so 1 over 0.6. 1.6 repeating. Either one of these here. Now, what are the only two that we're missing? Tangent and cotangent. Tangent is sine over cosine. Well, that's 0.6 over negative 0.8. And again, we can plug this into the calculator. 0.6 over negative 0.8, negative 0.75 or negative 3/4. Cotangent is the flip the tangent. Questions on how we got all this? All right. Well, we said this angle lied in the second quadrant, yes? Now, sine is 0.6. Or 3/5. Because our trig functions work a little bit better fractionally than they do as a decimal. So 3/5. And the reason I do this is sine is what? Opposite over the hypotenuse. So opposite side for that angle would be 3. Hypotenuse would be, what would the adjacent side be? Any guesses? 4. Specifically, for this case, it would be negative because we're in the negative x-axis. So we keep the signs true to the points on the coordinate plane. Okay, let's see how that helps. Cosine of theta. Looking at the triangle, adjacent side would be negative 4. Hypotenuse would be 5. Negative 4/5 is negative 0.8, which is exactly what we got. Cosecant of theta is just the flip of sine. 5/3 is what we got, 1.6 repeated. Secant of theta here would be negative 5/4 or negative 1.25, which is still what we got, yes? Yes. Tangent of theta is indeed sine over cosine. Well, we have the triangle, yes? Opposite over adjacent would be 3 over negative 4 or negative 3/4, negative 0.75. Isn't that what we got? And cotangent would be negative 4/3. We can still get there using the triangles, because when in doubt, make a triangle. Questions on this here? Common trigonometric values of common angles. Sine. We have 0, 1/2, square root 2 over 2, square root 3 over 2, 1, 0, negative 1. Cosine 1, square root 3 over 2, square root 2 over 2, 1/2, 0, negative 1, 0. Tangent 0, square root 3 over 3, 1, square root of 3, undefined. So, if we wanted to evaluate these using reference angles, again, With radians, we need that angle between pi over 2 and 0. 0 and pi over 2. Well, 4 pi over 3 is down in the fourth or third quadrant. Okay. Probably questions on how I found that. So in radians, straight up is pi over 2, yes? If I didn't say pi, what would the number value be? So if I remove pi, we're left with what on top? 1 over 2 is a half, yes? So looking at 4 pi over 3, is 4 over 3 bigger than a half? Yeah, so it's past pi over 2. Pi is just 1 pi, yes? Is 4 over 3 bigger than 1 pi? 4 over 3, is it bigger than 1? Okay, we're past that. Straight down is 3 halves, yes? Is 4 thirds going to be bigger than 3 halves? Maybe, maybe not, probably not, right? So what quadrant are we in? Because if it contains pi, well, all of our main ones do contain pi. So we're just looking at the number and comparing them. So here our reference angle is going to be that amount there. So we have to take pi away from it. So really this is going to be the same as saying cosine of 4 pi over 3 minus pi. So cosine of 4 pi over 3 is going to be similar to cosine of pi over 3. And at this point here, we can pull out our reference or our unit circle to find the value of pi over 3, which I think is square root of 3 over 2. Yep. Cosine of pi over 3. Sorry, it is 1/2. So this here is indeed a half. But in the third quadrant, cosine is negative, so it'd be a negative half. Calculator can do it still. Now again, knowing this is for a different time, because again, knowing these and this was helpful because again, when we couldn't easily calculate all angles of sine, cosine, tangent, because computers can do it just fine, we would have a table between 0 and 90 degrees, or 0 and pi over 2. I had sine, cosine, tangent for all those angles within reason from 0 to 90. And that's still a pretty, because you're looking at 90-some calculations. But if I knew that 4 pi over 3 would give us the same value as pi over 3, I don't need 4 pi over 3. I just need pi over 3 and know how it relates to this here. And I can still calculate that angle. You all see how that, and that's the nice thing is this here, I could give you a sheet from 0 to 90. We could calculate all of them with just that small amount. But technology today makes it a little less useful. Here, since we probably don't want to work with a negative angle, we can add 360 to it. All I'm doing is bringing it back to being between 0 and 360. Well, 150 is where? $150 degrees is in the second quadrant. So we have to take our 150 and subtract it from 180. So we'd have 180 minus 150, which is telling us we're looking at tangent of 30. Oh, wait. Yep. I go back here. Tangent of 30 is square root 3 over 3. And it would be negative because tangent's negative in the second quadrant. Mainly because tangent's only positive in the first and third. Are the only places where it's positive. So the second, fourth, it's negative. Let's see here. Nope. Switch this over. Oh, no. Might as well leave it. 30xs mode degrees. Tangent of negative 210 is negative square root 3 over 3. Just like we have, yes? All right, let's look at the last one. Cosecant of 11 pi over 4. Well, is that bigger than our circle? How many fourths would make 2? Think about it. So if we cut it into fourths, so if I cut 2 pizzas into fourths, how many slices would I have?
Wait, what?
If I had 2 pizzas and I cut them both into fourths, how many slices do we have? 8. So really, anything over 8 fourths would be bigger than 2. Is 11 fourths bigger than 2? Yeah, so we cleared the circle once and then are starting to go back around, yes? So might as well take 2 pi away from it. So we're at 3 pi over 4, yes? Okay. 3 pi over 4, well, that's bigger than pi over 2, yes? So we're sitting in the second quadrant for 3 pi over 4. So to find our reference angle, well, CSC, we took 2 pi away from it to make it be between 0 and 2 pi. Now to find its reference angle, I'm going to take pi and subtract 3 pi over 4 away from it. Okay? Without a calculator, can y'all figure out what 3 pi minus 3 pi over 4 is? It's pi over 4. Because really both of them have pi. Pi is going to be in our final answer, yes? So the number in front of pi is 1. How far away is 3/4 from 1? 1, right? Because we only need one more to go from 3 to 4. 4/4 is 1. So it's 1/4 or pi over 4. Cosecant is the same as 1 over sine of pi over 4. Sine of pi over 4 is square root 2 over 2. I think this is just square root of 2. Or we can plug it into the calculators, 1 over sine of 11 pi over 4. And what should we get? we should get the same answer, yes? And the answer we should get is square root of 2. And we get what's our calculator set in? And we put in a radian amount. So we have to be careful. Questions on this here? Is this not as daunting as it first seemed? Yes, sir. Yes. I don't think we need to see this again.